as you come down the series, their discharge, right, or their ability to get discharge at the electrode will increase, right? So we say this is as increasing ease of discharge as you come down the series. Here also we say it is increasing ease of discharge, right? So whenever you have more than one cation or an ion, just look at the series, right? So the one which is below in the series will get preferentially discharged compared to others, right? So since here we have sodium ion, chloride ion, right, and hydrogen and hydroxyl ion, these are two anions and these are two cations, right? So between these sodium and hydrogen, which is below? Hydrogen is below. So as per this rule, hydrogen should get discharged at the electrode. Similarly, among chloride and hydroxyl, this hydroxyl is below, right? So hydroxyl will, this OH will migrate to anode, and as per the series, hydrogen should migrate to the cathode, right? So the one, I'll repeat, so the one which is below in cations and anions will get preferentially discharged at the electrode, right? So this is selective discharge of electrode, selective discharge of ions at electrodes. But this selective discharge, in addition to this, also depends on other factors, right? So selective discharge, we know what is selective discharge. Both anions and cations will migrate to respective electrodes, but one of the two will react to give product at the electrodes, or we also call it as one of the two will discharge at the electrode. We call this as preferential or selective discharge of at electrodes, or selectively one of the ions will discharge at the electrode. So selective discharge also depends on concentration of ions in solution, right? And the second is nature of electrodes. Right? So concentration of ions. If we talk about the first point, concentration of ions, the ions which are in maximum concentration would get preferentially discharged as per the concentration of ions. This is what concentration of ions says. The ions, right? The ions which is in higher concentration will preferentially discharge at the electrode, even if the other even if the ion is below in the even if the ion is above in the series, if it is in more concentration, then that ion will discharge, right? Nature of electrodes. Electrodes, we have two types of electrodes that we would be studying in future lectures. One is active electrode, the other is inactive electrode or inert electrode. Inert electrodes are of carbon, right, or platinum, right? Inert electrodes are those which will not react with the product of electrolysis. Suppose we have chlorine gas or bromine gas that will get formed, right, at anode, right? So anode should be such that it will not react with the bromine gas, right? These types of electrodes are called inert electrodes. Why? Because they don't react with the product of electrolysis, right? So nature of electrodes, on nature of electrode it depends what is the product that we obtain at the electrode, right? And electrodes, we will study the electrolysis of copper sulfate, right, in future lecture. In electrolysis of copper sulfate, if we perform electrolysis of copper sulfate with copper anode and copper cathode, right, then at anode, right, when the copper is of anode, we would not get any product. Instead, copper will ionize. We'll just understand this. Don't just concentrate that on in this lecture. The product at electrode, at anode would be different if we take copper anode, right? But if we take platinum anode in the same electrolysis of copper sulfate, we will get oxygen at anode, right? So I'll just take down here the ion in higher concentration will discharge at electrode, right? Even if it is above in electrochemical series, right? For example, if we talk about the similar electrolysis of brine solution, that is sodium chloride, we have chloride and hydroxyl ions, right? But in electrolysis of sodium chloride, this chloride ion is in higher concentration, right? Chloride ion is in higher concentration in sodium chloride electrolysis, right? Although among these two ions, although OH ions, hydroxyl ion lies below it, below chloride. Since chloride ion is in higher concentration in sodium chloride, so in sodium chloride electrolysis, right, although OH ion lies below it, chloride ion will discharge at anode, right? Because of its higher concentration, chloride ion will discharge at anode, but OH ion will not discharge at anode because OH ion is in less concentration in solution, right? So whichever is in higher concentration will discharge at the respective electrode, right? And the other ion, even if it is below, right, but is less in concentration, will not get discharged, right? So, and the nature of electrodes, if we talk, electrodes are of two types, right? Depending on the nature of electrode, product of electrolysis will vary. May vary, right? And electrodes, I've just discussed, electrode may be active electrode or inert electrode. If it is a inert electrode, it will not react with the product of electrolysis, and if it is an active electrode, say platinum, then it may react with the product of electrolysis, right? And depending on the electrode, like we said in case of copper sulfate solution, in the electrolysis of copper sulfate, when we used platinum anode, the product obtained at anode was oxygen, right? Whereas when we used copper anode, the product obtained is different. Copper started ionizing into solution, right? So I hope all this is clear. Preferential discharge of ion and about this electrochemical series. Just remember one thing: if you check discharge of ions or which ion will react at the electrode based on this series, the one which is below in whether it is cation or anion, the one which is below will discharge preferentially compared to the one which is above. That's why I've mentioned here, as we come down the series, it's increasing ease of discharge, right? As you come below, it's the ease of discharge will increase. That is, the one that are below will easily get discharged at the electrode in both the cases, right? Just take down all the notes, and this is very important for further for study of different electrovalent compounds when we have more than more than one anion or cation, right? And nature of electrodes is equally important, because we would be using different electrodes, right, in when we do electrolysis of various compounds. Thanks.